Hello, great to see you again. Thank you for coming back. Okay. The setup for our particular problem here is going to deal with making a sinusoidal model for daylight, right? And we're going to be doing this work without much data to work from. Okay. It says that, hey, we have this old farmer's almanac that talks about the number of hours of sunlight in Boston on the summer solstice, which is the longest daylight of the year, and that's 15.3 hours of daylight, and on June 20th. And the number of hours of sunlight on the winter solstice, that's the shortest daylight of the year, and that's 9.08 hours on December 21st. Okay? It says to find the amplitude, period, and vertical shift for a sinusoid that could model the hours of sunlight. Right? Think what you might do. Pause the video, try it out yourself, and then come back and check your answer. Did you pause the video? Did you try it on your own? Okay. Well, to find our amplitude, we're going to need to know what the maximum is, what the minimum is, find their difference, and divide by 2. For the period, we're going to need to know what is the length or the time or the space, right? How long does it take to repeat our repeating pattern? Right? And for our vertical shift, we need to know the max, we need to know the min, find their sum, and divide by 2. Okay? So let's do that. Okay? So our amplitude will be our maximum minus our minimum divided by 2, which is about 3.11. Our period, a year, right, for the daylight to repeat is about 365 days. Of course, leap years and all of that, and you can look into the history of adjusting calendars to match the Earth's revolution around the sun. Okay, and vertical shift, maximum plus minimum divided by 2, about 12.19. Okay, so using that information, we want to determine the sinusoidal function to approximate, and this should say the hours of daylight in Boston starting on the summer solstice. So we're going to say, let's do this at first by starting on the summer solstice. Okay, so what would that look like? Okay. The form of our equation would look something like this: A cosine bx plus k, without any sort of horizontal transformation. Okay, and cosine function, because on the summer solstice, that's the longest day of the year, so that would be starting at a maximum, and starting at a maximum would be the cosine. So what would be our equation? Well, our equation could be given by y equals our amplitude, cosine, starting at a max, 2 pi over our period, times our variable, I'm going to use t for time, plus our vertical shift. Right? So our amplitude, 2 pi over our period, because the cosine has a traditional period of 2 pi, but we're going to set it up as a period of 365, and then plus that vertical shift. So this is the sinusoidal function for the hours of daylight starting on the summer solstice. What about the next part? Sketch 2 periods based on part B. So much as we've done all along, if we set up our information and we say, hey, we're going to start at a positive cosine starting on this summer solstice, right? Well, our center line is 12.19, right? Our max 15.30, our min 9.08, and we know that those are the same distance away from our center line, right? I can do 1 quarter, 2 quarters, 3 quarters, a full period, and I know that a full period is 365 days, and then 1 period, 1 quarter, 2 quarters, 3 quarters, a full period. But with this 365 and those tick marks, I've labeled my horizontal axis, right? Start at a max, go to the middle, go to a min, go to a middle, go to a max. Go to the middle, go to a min, go to the middle, go to a max. And much like we've done all along, there is my general graph for 2 periods of the sinusoid from part B. Okay. Now, how would our equation change if we wanted to start on January 1st? Okay. Well, if we wanted to start on January 1st, then we have to include a phase shift so that our maximum is going to occur on June 20th, right? And whatever day of the year that is. Okay, well, how are we going to figure that out? Well, June 20th is going to be the 171st day of the year, right? 171st day of the year, what does that mean for us, right? That means, how did I get that? Excuse me. January, February, March, April, May, and then June 20th. Add up those days, June 20th is the 171st day of the year. So how do we write an equation of this form based on starting January 1st? Well, we can start to set up our idea. We'll say, hey, right, y equals, our amplitude's not changing, cosine of, right, well, let's do this real quick. Let's delete. 2 pi over 365 is 0.0172. Right, so we'll go ahead and use the decimal here, 0.0172, to represent 2 pi over 365. And then we have parentheses x, and we're going to have some sort of phase shift. And then we know plus 12.19. Okay? And of course, we can check this on our calculator to make sure we have the phase shift correct. So on our calculator, we can go to the y equals, put in our equation, 3.11 cosine 0.172. And we said that June 21st is the 171st day. So our initial thought is, hey, let me just say that I would move that 171 days to the right if my first day was January 1st. And then plus this 12.19. Right? So I could come over here, go to my window, right? Let me check from 0 to 365, so I'm thinking about a full year, right? My max and my min, I want to make sure I can see everything, right? So I want to make sure that I can see the minimum, so I'm going to say 9. I can see the maximum, so I'm going to say 16. And I'm going to graph that. And I'm going to come over here and I'm going to say, ooh, right? That seems to be a little bit off. Well, let's check our mode. Our mode is in radians. We should be in radians. Right? Let's just double check some of our work. Right? So we come back to our equation and we say, oh, look, this is 0.172, not 0.072. That's a common mistake that we might make. So we want to make sure that we actually write it correctly and come back, look at our graph, and we say, oh, okay. Now that looks much better. Right, that looks much better for our piece. We have one period, right, and we want to make sure that this, right, maximum occurs around 171. So let's check that out. Okay, so second, calculate our maximum. Right, let's go a little bit to the left of the maximum, a little bit to the right of the maximum. Right, calculate it, and we see that in fact there it is, 170.99. So we're good that on the 171st day we're at a maximum. So yes, indeed, minus 171. Okay, so an equation of this form based on starting January 1st. Here it is, right? And all I did was say, hey, my maximum was starting at 0, but now it needs to be on the 171st day of the year, so I'm just going to move 171 days to the right. Okay? Do be careful that you're entering information in your calculator correctly. All right, so what about part E? Now we're asked to write this equation with a sign based on starting January 1st. So what would that look like? Well, once again, we'd have this general form, right? Amplitude hasn't changed, period hasn't changed. This is 2 pi over the period. Right? And the vertical shift hasn't changed. The only thing is our phase shift will have changed. So how can we figure that out? Well, I can come back to my equation. So here's my equation. We said this is a good looking equation for what we have. And I'm going to come back over here. And on y2, I'm going to put 12.19. Excuse me. Always be careful on what you're entering. And I'm going to graph that. And I want to find this intersection point here because that would be the movement to the right to represent starting for a sine. So to do that, right, to do that part, I'm going to go second, calculate my intersection, my arrow down to get onto this equation, right, I'm on 12.19. Arrow close to the point of intersection, that's pretty close. Enter once, enter twice, enter thrice, and I have my value, which this value is about 79.67, right? So that's going to represent my phase shift. So minus 79.67, okay? And we can always double check that we've done this correctly. Alright, so I'm going to come back to y equals, and I'm going to try this out, 3.11 sine parentheses 0.0172 parentheses x minus 79.67 close parentheses twice, and then plus 12.19. Alright, and I can come over here and adjust what my graph's going to look like. I like to do the little bouncing ball so that I can double check that everything looks good. And I see that bouncing ball, it's tracing my graph in a similar fashion, and so that lets me know that yes, in fact, this equation and this equation are going to be representing the same thing. And here's a final way that you can check it out. Okay, watch this. If I come over here to my initial piece, right? Well, let's go back to y equals y1, y3. Okay, so if I come over here and I say alpha, the green button, right? Alpha trace, right? And I say y3, and I say, well, what is y3 on the 171st day of the year? Is that my maximum? 15.3. Yes. Well, that's good. How else can I check it? Well, I know that my winter solstice is on December 21st, right? December 21st is 10 days from the end of the year. So that means it's 10 days short of 365. So I could also come over here, right, and say, well, let me check my equation at 365, not at 365, excuse me, at 355, and say, on the 355th day of the year, am I close to that minimum? Yes, I am. So I can double check that my equations are all correct. So once again, what was the process here? Right? Well, to find the amplitude, I need max minus min over 2. The period is how long it takes to repeat. The vertical shift, max plus min over 2. To get a basic function starting at a maximum, I'm going to use cosine, right? And I can set it up. I can draw that basic function, right? Make sure I label everything. Right? But if I'm going to change it so that I start on a different day, well, I need to figure out, well, what's the distance from where I'm starting to where I would like to start, or where I thought about starting, right? The distance from where I'm starting to, in this case, the maximum, was 171 days. So I'm just going to put a phase shift of 171. Right? And this 2 pi over 365, it's okay to write it as a decimal. I'd recommend 4 decimal places for the period if you're not sure. And then similarly, if I want it to be a sine function, I can come over here, right? Graph, find where that equation would start if it was a sine function. And in that case, we found that it would be a phase shift of 79.67 days. Okay? Very nice problem. You can see a different way of solving it on page 427 of your textbook in section 6.6, right? But this is a common format that you need to be familiar with.